When astronaut Scott Kelly returned to Earth after a year aboard the International Space Station, he was exactly 8.6 milliseconds younger than his twin brother. This microscopic age gap is a direct result of special relativity, the physical law Albert Einstein established in 1905, showing that clocks in motion run slower than clocks at rest. This chart maps what happens when we scale that principle up to interstellar distances. Imagine a spaceship travels to a star 4 light-years away, cruising at 80% the speed of light. For the twin who stays behind on Earth, the round trip takes 10 years, but for the twin aboard the ship, the clocks show that only 6 years have passed. Here we hit a mathematical wall. Relativity dictates that there is no absolute state of rest anywhere in the universe. Because motion is entirely relative, the traveling twin is perfectly justified by the laws of physics to claim their ship is standing still, and it is actually the Earth receding from them at 80% the speed of light. If the math applies symmetrically, both twins have perfectly valid reasons to calculate the other should be younger. They cannot both be right. To resolve this contradiction, we have to look closely at the physical mechanics of the journey. The setup implies a perfect mirror image, but the twins' experiences are entirely different. The twin on Earth sits in a single, undisturbed inertial reference frame, a state of constant velocity with 0 acceleration for the entire 10-year duration. The traveling twin does not. To return home, the ship decelerates, physically turns around, and accelerates back toward Earth, forcibly shifting them into a completely new inbound inertial frame. This Minkowski space-time diagram plots time on the vertical y-axis against movement through space on the x-axis. The Earth twin's world line is a continuous vertical line straight upward. The traveling twin creates a bent triangular path diverging outward, hitting the turnaround apex and angling back. The contradiction disappears when you look at this map. The twins do not share the same physical path through reality, which means they do not share the same timeline. This diagram reveals a counterintuitive rule of relativistic geometry. Unlike drawing on a flat piece of paper, a straight line through spacetime actually results in the longest elapsed proper time, reading 10 years compared to the bent path 6. Moving rapidly through the spatial dimensions essentially consumes a portion of your movement through the time dimension. The bent path is literally a shorter duration. But does the biological clock slow down because of the intense, bone-crushing g-force required to physically turn a rocket around at near light speed? We test this with a relay experiment. An outbound clock and an inbound clock travel in opposite directions at constant speeds, crossing at the triangle's apex. The outbound clock transmits its timestamp to the inbound clock via radio signal. 0 physical deceleration, 0 turning. When that inbound clock arrives at Earth, the combined mathematical time of the 2 relay clocks is exactly 6 years, perfectly matching the scenario with the turning rocket. Gravitational forces and physical acceleration do not cause the age difference. The discrepancy is a pure, unavoidable consequence of taking a geometrically shorter path through the fabric of spacetime. When the spacecraft touches down on Earth, the traveler steps out biologically 6 years older, standing next to a twin who is biologically 10 years older. This is not a mechanical glitch affecting the quartz crystals or atomic sensors inside the ship's navigation computers. Every physical process in the universe, chemical reactions, neural processing, and cellular aging, is strictly bound by the geometry of the path it takes. We have to abandon the intuitive concept of time as a universal ticking clock hanging on the wall of the cosmos that everyone shares equally. Under relativity, time is a highly localized, personal pedometer that only tracks your specific, individual journey through the universe. The 18 gap between these twins prove that human